All right, hey there, pre-calcers. We're just going to do a couple of videos here going over the basics of composite functions. This is from lesson 2.5. So to start off, we're just going to define what a composition is. Earlier in the chapter, we talked about a function as being something like a machine where you plug in some input and it goes through and does its thing and then produces an output for the function. So a composite function or a composition is basically when we're just almost you can think about it like daisy chaining two machines together. So you just plug in something into your function, and really there you wouldn't even necessarily see this middle part. It kind of all flows continuously, and then we'd get this second output that would all look like one continuous process. So the way that we notate these functions, there's two different primary notations. You have this little mini circle. Uh, you can write a composition like this, or you can write one composition written as like the input of the function f right here. Both of these are equivalent expressions. We can use them interchangeably. And the way that you would read either one is just f of g of x. So what that means is we're going to take an input, we're going to plug it into G, and then we're going to take the output of G and plug that into F directly. Okay, so we can do this for both single values and also entire functions. We're going to start by looking at just how would you produce a function this way. So we're going to start with these two functions, f of x and g of x right here. And we're going to find the composition f of g of x. So just to start off again, just to restate this a little bit more clearly, we're going to input the function g of x, this one, into the function f of x here. So we're going to make the input of this f of x function the entire g of x function right here. So that means we're going to input x squared minus 12 into the function f, and that's going to look like this. So f of this g of x function, which I have right here. So now I'm just going to replace the x in my f of x function right there with x squared minus 12. So when I do that, I'm just going to place it there. We still have the minus 4. We still have the square root because that was where my function came from. So we can clean this up just a little bit, combine the minus 12 and the minus 4, and we get this function right here, x squared minus 16. Now, I want to ask a follow-up question here. A really common thing to do would be to say, all right, well, I've got two perfect squares here inside of a square root. So the square root of x squared is just x. The square root of 16 is just 4. So can I just write x minus 4? Well, no, we cannot. So that is not an allowed operation. This is a really common error that we see pre-calculus students making. And so you really want to watch out for this. If you're not careful, if you look at this, it looks like if for x equals 4, that would work. You'd wind up that being 0 right there, and it's 0 right there. But if you try any other value, say take x equals 5, for example, is an easy one to work out, you'll get different values for these two expressions. So this one right here is not a simplification that we can make. When you have a square root of two squares like this, we cannot simplify that any further. So the last part we're going to take a look at is the domain of this function, this composition. So we're going to look at the domain of this function right here on the next slide. Again, no, we can't simplify that anymore. All right, so what is the domain? Well, just a reminder, there are two things you want to be looking out for here. We can't divide by 0. We also can't square root a negative. So we don't have any denominators to worry about on this one. So we're just going to take the input of my square root function here, and I know that needs to be non-negative. So that means it needs to be greater than or equal to 0. Do a little bit of algebra here to solve. X squared needs to be greater than or equal to 16. When you take a square root, we've got to account for the positive and negative parts of the solution. So when I take a square root here, that means that x needs to be greater than or equal to 4, or the x needs to be less than or equal to negative 4. So when you take that square root, you have the plus and the minus, the positive and negative solution. So when you have an inequality, the positive solution part to the inequality the inequality points the same way. The negative one is the one that you flip. So for the negative 4, we got to flip that around. So that would be your domain. If we want to write that in interval notation, it would look like that. And on the next video, we're going to take a look at a composition with a mapping. And so I'll see you there.